All right, so our last part of the factoring and solving component is getting to calculator-based word problems. So we now know how to use the calculator to find where a parabola would cross or touch the x-axis. I now want to use that skill to be able to work with real-life word problems that have a parabolic motion. So we're going to look at a frog jumping, and then we're also going to go to Delta Math and look at what they ask with like a rocket taking off. So with this one, it gives you the equation for the height of the frog jump, where x is the distance from where it starts. So x is like going this way from jumping, and then y is going to be the height that the frog jumps. So you have your x, which is going to be a horizontal distance, so it's going to be jumping up into the air and then landing. We want to figure out how far the frog jumped. We want to figure out how high the frog jumped. So we want to use a lot of different things from this previous chapter to do that. So the first thing I'm going to do is I'm going to figure out where the vertex is, because if I can figure out where the vertex is, I have a pretty good idea of how I want to look at this in my calculator. So my vertex is the opposite of b over 2a. So I'm going to do the opposite of 0.59 over 2 times 0.029, and both of those are going to be negative, the top and the bottom, so those negatives will just cancel. So on my calculator, I'm going to type in 0.59 divided by parentheses 2 times 0.029, and that's going to be your x value. So it's going to be x here at the vertex. Let me get that number back again. It's around 10.1, 10.2. So I'm just going to kind of approximate that. And I'm going to use that to figure out basically how do I want to set up my window. I can also use that to figure out how high it jumped. So I'm going to take that number. I'm going to take that I'll go to 10.17 just to make sure it's a little more accurate. And I'm going to plug that back into this equation for x to figure out the y value or the height. So I'm going to type in negative 0.029 times, I said we're using 10.17. It will tell you how much it wants you to round. Squared plus 0.59 times 10.17. So we get 3. We get a y value of 3. So what that means is when it gets to the vertex, horizontally, the frog has traveled just over 10 feet, and vertically, the frog has traveled about 3 feet. So if we go to our calculator, I want to show you how this is helping us. We're going to go to the calculator. We already have some of our answers, but I want to add a little bit to it. We're going to type in our equation, negative 0.029 x squared plus 0.59x. And I want to show you something that we haven't really done in class, which is adjust the window of your calculator or the screen that you're seeing when you graph it. If you just hit the button that says graph, it will automatically show you something that goes 10 in each direction. That may not be what I want. I may want to adjust it. So here's the way you adjust it. You're going to go to the button that says window. So let me kind of highlight this for you. This is the button that says window. If you click that button, what you're going to see is the standard, kind of like the default window, which means it's going 10 left, 10 right, 10 up, 10 down. I don't want that boundary. I don't think I'm going to see it very well. So I want to start at 0. So my x is going to be kind of my starting distance. Sometimes x is starting time. Either way, I don't want a negative. I'm not going in a negative direction. My maximum x, well, I know the vertex happens at 10.2, which means that's only halfway into the jump. I need to go another just over 10 feet. So I'm going to make my maximum go over 20 because I know that's when it should hit the ground. So I'm going to go like 25. It's probably more than I need, but better to be safe. And then my y minimum is my height. Well, again, I can't really have anything other than 0. You might want to put -1 just so you can see under the axis a little bit. So you could do 0 or -1. I'm going to do -1 just so you see under it just a little bit. And then my height, well, it only got to a height of 3. So I want to make sure that my height, it doesn't need to be much more than 3. I'll go 5 just so we can see it. Once you adjust your window, if you like how you adjusted, if you hit the graph button, it will show you that new window. If you don't like what you did, you can go back to window. You can hit window again and say, no, I don't like how I changed it. I can't see enough of the path, and you can continue to tweak it. So here's the path of my frog. My frog jumps up, it hits my vertex, and then it comes back and hits the ground. So the first question, now I'm actually going to go and answer my questions here, is how high did the frog jump? So I already know that the frog, sorry, the first question was how far it jumped. I'm going to do how high first because we already know that the highest it ever got is it went to a height of 3 feet. For how far did the frog jump, I want to find when it gets to the ground, which is where it crosses the x-axis. So I am looking for this spot right here. So to do that, I'm going to use that 0 button again. I'm going to go to second, trace, 0. I want my cursor to be before it crosses. I can just hit enter now. And then you can either hit the right arrow, or you could say, you know what, I think it's going to cross somewhere around like a little bit more than 20. So you could actually just put like 21 and it would take you to after you think it crosses. So you can actually manually type in a number just to make the cursor move faster. You can type in an X value. Now I'm going to hit guess. So here we go. My frog, travels 20.3 or 20.34 feet before it hits the ground. So 20.3 feet is how far it jumps. I can also answer the next question. The next question wants to know at 16 feet across, how high was the frog? The way I'm going to get that is I'm going to use the value button. So I'm going to go to second and trace, and I'm going to hit enter on value. And I want to know how high the frog is after it's gone 16 feet. And you can see the little cursor kind of flashing there. It kind of blends in with the graph a little bit. At 16 feet, the frog is only just over 2 feet above the ground, so 2.016 feet above the ground. As far as domain and range, well, in this case, your domain is how far horizontally it travels. My frog started out at 0 and it went to 20.3. So that's going to be my domain. That's the total frog jump from left to right. And my range, he started out as a height, I don't know why I'm calling him a he, and then it never went higher than a height of 3. So my range is between 0 and 3. So let me show you what you're going to do on Delta Math, because I think it's helpful to see some actual examples. So let me get to Delta Math. So Delta Math is going to do rocket problems, and it's going to specifically ask you about the time it hits the ground. I am going to ask a few older things with finding the vertex. Those are things we've done previously, but I really want to focus on the hitting the ground here. So here's what I know. I have my rocket. X is going to be the seconds that it's in the air, and then Y is going to be the height that it is at that particular time. And it wants to figure out when it's going to hit the ground to the nearest hundredth of a second, so 2 decimal places. First thing you want to do here is figure out where the vertex is. So my vertex is going to be at the opposite of B. So opposite of B is negative 165. I know the negatives are going to cancel, so I'm just going to type in 165 divided by 2 times 16. So my vertex is around 5.15. That would be seconds. So that kind of gives you an idea of how many seconds it takes to get to the peak. So to get to the ground, it's probably going to take about double that. It's usually not perfect because it kind of depends on where we launch this rocket from. But we know that it's going to take somewhere in the neighborhood of 10 seconds to get back to the ground. And then my height would be when I type negative 16 and I put this number, I'm just going to say, I'm going to go 5.16 because it says nearest hundredth. Squared plus 165 times 5.16 plus 69. So that's how high my rocket gets. And the reason I did that is I want to have a really good idea of how to set my window. So when you go to your window, it looks like the rocket travels almost 500 feet in the air. So I'm going to go to y equals, and I'm going to type in this equation for my rocket. So I'm going to type in negative 16x squared plus 165x plus 69. And I'm going to go to my window. This was the window I used for my frog jump. Well, now the time, it took about 5 seconds to get to the peak, which means it's probably going to take about another 5 seconds or so to get to the ground. So I want my maximum to be somewhere above 10 seconds. I'm going to go 15 just because I want to make sure I get everything in there. You could do 12. If you don't like how you said it, you can change it. And then my Y, the maximum height. So we saw when the vertex was like almost 500. So I'm going to have my Y go all the way to 500. And if I hit graph, There is my rocket, fits really nicely, and you can see the path of the rocket over the period of time. It specifically wants to know when does it hit the ground. So again, I'm using the 0 button to see when it crosses or touches the x-axis. So I'm going to go to second and trace. I'm going to hit the 0 button. I'm already before it crosses, so I'm going to hit enter. So I think it crosses somewhere around 10 seconds. So I'm going to put a number a little bit bigger than 10 seconds for my right bound. And it is negative. You can see the y value. So it has crossed through the axis. And then I'm going to hit enter. And there it tells me that my rocket will touch the ground at 10.71. It wants us to go to the nearest hundredth, so 10.71 is appropriate. So I'm going to type in, switch my keyboard. Give me 1 second so I can switch my keyboard. I'm going to type in 10.71 for my seconds. Submit that. And then it will show me my parabola that I just saw on my calculator screen, and it will give me that value. It will remind you that the parabola does touch before things started. You can't have a negative answer for that, so that's why we're not even considering that part. We're only looking at the positive answer, which is 10.71. So that is how we're using the calculator and word problems to figure out things like when a frog hits the ground or when a rocket hits the ground.